Hello friends, welcome to the channel. Today we are going to start electrochemistry. Electrochemistry is an important chapter in both CSI net and GATE point of view. It is also an easy topic and also mark scoring one. So come on, get started. So in electrochemistry we are going to study about electrolytic conductance. Electrolytic conductance. So first let us study about electrolytic conductance. So you might have heard about metallic conductance. So we'll get a idea of metallic conductance, then go to electrolytic conductance. So we all know metal are good conductors of electricity. Good conductors. So in metals the conduction is due to free electrons. So in metals there are excess of free electrons, right? So due to the movement of free electrons, conduction is happening. So the conduction is due to movement of free electrons, right? So the movement of free electrons is responsible for the conduction in metals. So it is called as metallic conductance or electronic conductance. Due to movement of free electrons, conduction is taking place. So it is called as electronic conductance. Conduction. So electronic conduction and metallic conduction are the same. Due to the movement of electrons, conduction is happening. So it is called as electronic conductance. So in metals the conduction is due to movement of electrons. Okay, now we are considering solutions. Okay, the solution, the conduction is due to movement of ions of electrolyte. So the conduction in solution is due to movement of ions of electrolyte. So what are electrolytes? Electrolytes may be strong acids, bases, okay, fused salts, okay, or their aqueous solutions. Okay, so electrolyte may be these things. Okay, so if suppose you are taking a beaker, okay, taking electrolyte, considering aqueous NaCl solution. Okay, now taking two electrodes, okay, and you are applying some potential difference. Okay, some potential difference is applied. Okay, now so this is positive electron, this is negative electrode. So positive electrode is called as cathode, right? And this negative one is called as anode. Okay, so when NaCl is dissolved in water, the ions split as Na plus, get associated to Na plus and Cl minus. So this Na plus, the positive electrode is anode and negative electrode is cathode. Okay, so this Na plus ions being positively charged get attracted towards cathode and Cl minus ions get attracted towards anode. So the mobility of Na plus ions and Cl minus ions to their respective electrode, okay, is the cause for the conductance. So it is called as ionic conductance. So the movement of Na plus and Cl minus ions are responsible for the conduction in solutions. So it is called as electrolytic conductance. So in metals, the movement of free electrons are responsible for conduction. It is called as electronic conductance. And in solution, the moment of Na plus and Cl minus ion, that is the moment of electrolytic ions are response for the conductance, hence it is called as electrolytic conductance, electrolytic conduction. Okay, now we have studied about conductance and conduction. Now let us see some important terms in electrochemistry. So first we'll study about conductance. Conductance. So conductance is denoted by the letter G. So what is conductance? It is the ease with which electricity flows through a solution. So conductance is defined as the ease with which electricity flows through the solution. So it is a measure. Okay. So it actually measures the ease with which electricity flows through a conductor, and conductance is the reciprocal of resistance. So you all know what is resistance. So resistance is that resist. So which resist the flow, the current flow through the conductor or to the solution, and conductance is the ease with which electricity flows through the solution or to the conductor. So we know the unit of resistance is ohm, denoted by the symbol, and conductance is the reciprocal, ohm inverse, or it is also called as mho. So these are the CJ's unit, and in SI unit it is given by S, meaning Siemens. So next we are going to see the topic specific conductance and specific resistance. First we'll study about specific resistance. Okay, specific resistance is given by denoted by the letter rho. Okay, and rho is equal to R A by L. Here R is the resistance, A is the area of cross section, and L is the length. So the unit of specific resistance or resistivity is resistance ohm, right? Area centimeter square and length is centimeter. So we get ohm centimeter. This is a unit for specific resistance. So if you want to know specific conductance, is just the reciprocal of specific resistance. Specific conductance is denoted by the letter kappa, and that is 1 by rho. So now we'll find the unit of specific conductance. So kappa is equal to 1 by R L by A, because it would be the reverse of the specific resistance. So 1 by R would be mho, and this centimeter by centimeter square would give you mho per centimeter, right? That would be given Siemens per meter in SI unit. So this is all about specific resistance and specific conductance. Okay, now we are going to study about equivalent conductance and molar conductance. So first we'll study about equivalent conductance. So what is equivalent conductance? So if suppose we are dissolving 1 gram equivalent of electrolyte in solution. Okay, so you are dissolving 1 gram equivalent of electrolyte in the solution. Okay, so electrodes are placed at distance of 1 centimeter apart, and potential difference is applied. Okay, now conduction and movement of ions takes place, and conduction occurs. So equivalent conductance is defined as the conducting power of all ions produced by 1 gram of electrolyte in the given solution. So when 1 gram of electrolyte is dissolved in a solution, in the electrolytes kept at 1 centimeter apart, now ions will be produced, right? If suppose we are taking NaCl, when dissolved in water, Na plus and Cl minus ions is being dissociated, and the conducting power of these ions is called as equivalent conductance. Equivalent conductance is denoted by the letter lambda, and that is equal to kappa into V. Kappa is the specific conductance and V is the volume of this solution containing 1 gram equivalent of the electrolyte. Okay, so we can also write this equation as lambda is equal to kappa into 1000 by C, where C is the concentration in gram equivalents per liter. Okay, the unit for equivalent conductance is given by ohm inverse per centimeter cube by equivalent, because for specific conductance it is mho per centimeter and this is concentration in gram equivalent per liter, so centimeter cube by equivalent, so we get mho per centimeter, mho per square equivalent per equivalent. Okay, mho centimeter square per equivalent. This is the unit for equivalent conductance. So next we are going to study about molar conductance. So molar conductance is just similar to equivalent conductance, but here we are going to consider 1 mole of electrolyte. So there we consider 1 equivalent of electrolyte. So we took 1 equivalent of electrolyte and we consider the conduction of the ions produced by it. Here we are going to consider about 1 mole of electrolyte, and here it's given by the formula lambda m is equal to K into 1000 by Cm. We can write K into 1000 by molarity. Okay, K into 1000 by, the unit is given by Simon, meter square mole per inverse. Now there is another term called cell constant. Okay, so what is cell constant is, if we take resistance is equal to rho L by A. So the L by A term is called as cell constant and denoted by the K cell. Okay, and the unit for K cell is, for length, centimeter by centimeter square gives per centimeter or per meter.